Okay, so Pythagorean theorem review is what we're going to do first. You don't have to write this down if you just want to pay attention. All right, so you guys all have heard of it before. Do you remember what it is? Good, it's a triangle thingy.
Yep.
Okay, we have two sides or two legs.
Extra credit.
In a little bit. And then we have the hypotenuse. The hypotenuse is always going to be your longest side across from your right angle. Okay, so the formula is a squared plus b squared equals c squared. It is possible to get decimals with this. If you do get a decimal, you can either leave it in round it or you can leave it in radical form. Okay, so just a real quick example. If I gave you the legs 5 and 12 and said to find c, you would do 5 to the second power plus 12 to the second power equals c to the second power, which is going to be 25 plus 144. We add those together, we get 169. So then we take the square root of 169. That's the opposite of squaring. And that actually equals 13. So we're going to need this to do what we're learning today. So that's why I kind of wanted to review it real quick with you. You have food. Well, there's not much in there. Well, I'm going to go down to concessions later. Yeah, when I go down there. Yeah, I'm going to go after second block. Yeah, but I'll help you first. All right, everyone's okay with Pythagorean theorem? We'll do examples together so you'll see it. Look at Cash's back. It's got a
Gross.
All right, so we're going to go to our notes page. Good? All right. All right, so our notes page is called Centers of Triangles. We actually constructed this circumcenter and the incenter when we did the compass constructions. So now you're going to actually do the math part of it, not the construction part. There are 4 centers of triangles. We're doing 2 today, and we'll do the other 2 tomorrow. All right, so the first one is called a circumcenter. And this is when the perpendicular bisectors of the sides of a triangle intersect at a point called the circumcenter. Okay, so it's where 3 perpendicular bisectors intersect. So you can see in the picture, point P is going to be the circumcenter. Now, the way you can identify the circumcenter is that you'll see these perpendicular bisectors, or you'll see that little right angle, and then you see that the segments are the same, which means they've been bisected or broken into 2 equal parts. All right, now the circumcenter is always equidistant, so that means the same distance from the vertices of the triangle. So if you remember when we did our compasses, that's where you did the triangle, I'm sorry, not the triangle, the circle around the triangle. So PB is going to be the same as PA same as PC. Let's go ahead and we'll do 4 little marks since we already got the 1, 2, and 3. So if you opened your compass, you could spin a circle right around that. All right, so the perpendiculars are going to be PF, point P to point F, point P to point D, and point P to point E. Those are the perpendicular bisectors, just so you see them. The circumcenter is going to be at point P. Now it says list all congruent statements. You don't, I mean, we could do it, but it's a lot of work. Basically, we've got AD is congruent to BD. We've got BE is congruent to CE. That's these two. We've got AF is congruent to CF. Those are the bisected segments. And then we have the 3 segments to the vertices, which would be PA, PB, and PC. Okay, so that's just identifying the parts. When you're practicing, the things you need to remember is that the segments are congruent, and then the center to the vertex is congruent. All right, so we have 3 practice examples here. So it says if Z is the circumcenter of triangle TUV, find all the missing measures. Okay, so if that's 19, we know this is going to be 19. If that's 34, we know these are going to each be 17. Let's see what else we know. Okay, we know Z to V is 21, so that means T to Z is going to be 21, and U to Z is also going to be 21. All right, so TU would be this whole segment. That's going to be 38. VY is going to be 17. UZ is going to be 21. WV we don't have yet, but we'll solve that in a minute. And TV we don't have yet. All right, so how do you think we could find WV? Anyone have any ideas? Being what we just learned, we have a right triangle here. So we could do 15 squared plus an unknown squared equals 21 squared. Because you could see right here we have a right triangle. So if we were to solve this, 21 squared is 441. Yeah, you do, but that's the one we need because we're looking for WV. 225. So then x squared is going to equal 216. So x is going to approximately equal 14.7 if you do the square root on the calculator. So that means WV would be 14.7. And then it asks what TV would be. So this would be 14.7 plus 14.7, which is going to be 29. I can't add. 29.4.
That's 29.4.
Yeah. 14 and 14 was 28, but I messed up.
why'd you square it?
You square root it. The formula is squared, and then you do the square root of 216 to get x by itself. So you know how the opposite of adding is subtracting? The opposite of squaring is square rooting. Okay. So again, our segments are bisected, which means we have equal segments. We have the right angles, which will take us into Pythagorean theorem. And then we have from the center to the vertices is congruent. All right, let's look at the next one. I always just fill stuff in first because that kind of helps me before I answer. If CE is 7, then EB would be 7. BD is 24, so each of these would be 12 if it was bisected. We know that BH is 13, so CH will be 13, and DH will be 13. So again, we're going to have a right triangle right here.
BC is 14 because EC is 7. That's 12.
Right. Good. Okay, so if we start filling in what we have, GD would be 12. BC would be 14. EH is going to be, we don't know what EH is. So to find EH, we're going to have to use Pythagorean theorem. We have a leg of 7 and a hypotenuse of 13. So we would do 7 squared plus x squared equals 13 squared. So that's actually this right triangle over here. All right, so 7 squared is 49. 13 squared is 169. So we get x squared equals 120. And the square root of 120 is 10.96. So if we round to the nearest tenth, we'd actually round to 11. So EH would be 11. All right, next it asks us what FD is.
Wouldn't that be 24? Or wouldn't that be 12?
Nope. We've got another right triangle right here. This is a different color. So that's going to be for FD. It's going to be 3 squared plus x squared equals 13 squared. So it's going to be 9 plus x squared equals 169. So x squared is going to equal 160. And x would equal 12.6. You done?
Yeah.
That was quick.
Yeah, I guessed another answer.
All right, and then CD would be this whole length. So we're just going to double it, which would be 25.2.
Did you add EH and FD together? Because could you do that because
What'd you say? Can you add EH?
and F together so equal to 23? Because I mean EH is the same as CF and FD we just found. So
They're not the same, though. No. I already gave you yours yesterday, but if you need it,
Find the trash can.
it's in Jackson's spot. All right. Do you guys need to do one more of those, or no? You think you understand? Okay.
Is Bradley Manchester?
Yeah. All right, so when you're done copying, turn it over. We're going to go to Incenter. All right, so the Incenter is this point P right here. Okay, so we name the Incenter as point P. The difference in the Incenter and the Circumcenter is this is based on the angle bisectors. So the three angle bisectors, PB, PC, and PA, of the angles of the triangle intersect and called the incenter. Now the incenter is always equidistant from the sides of the triangle. So that's going to be these three sides. Okay. Don't be confused with the perpendicular bisector versus this. The way you know the difference is these are going to have these little angles congruent, where the circumcenter did not focus on angles other than the 90 degrees. All right. So the angle bisectors are going to be PB, PA, oh, no, yep, PA, and PC. All right. Now from yesterday, do you guys remember when they had an angle bisector, what happened to the sides? They were congruent. So AD is going to be congruent to AF. So it's different than the bisector, perpendicular bisector. FC is going to be congruent to EC. And then DB is going to be congruent to EB. All right, and then we also are going to have that little, I guess, kind of looks like a little pinwheel right here. We would have DP is congruent to FP is congruent to EP. All right, so again, the angle bisectors create the incenter. The incenter is equidistant to the three sides. And by doing that from yesterday, if you notice, that looks kind of like the little cone we cut yesterday, or the little kite. We have equal segments, and then we have 90-degree angles where it intersects.
What are the outsides of 90 degrees of a triangle supposed to be?
360. And I can show you that on a proof in a second. All shapes have an exterior angles of 360, no matter what shape it is, no matter how many sides it has. All right, so let's take a look at this picture. It tells you that P is the incenter. It says find each measure. So MP is 8, which means PO will be 8, which means NP will be 8. So NP is 8. All right, we know that OK is 17. What else will be 17?
NK.
Good, NK. All right, let's see what else we need to find. PK, PK, so that long one. So again, you're going to have a 90-degree triangle. So we're going to do 8 squared plus 17 squared equals C squared. Doing the math quickly on the calculator, we get 353 equals X or C squared. So C is going to equal 18.8, and that was PK. And then the last one, they ask us for LO. LO is going to be this segment over here. Again, we have a right triangle. This time you have the hypotenuse. So you're going to have 8 squared plus x squared. Is that LO? Yeah.
13 squared.
Hold on. I want to make sure I have LO is right here.
Yeah, that's all.
So 8 squared plus x squared equals 13 squared. Yeah. So we're going to get 169 minus 64. So we get x squared equals 105. And then the square root of 105 equals 10.2. And we get 10.2 here. Everyone okay? All right, let's just do one more just so we can practice together. So we're going to fill in EB is 6, so that means BF is 6. DC is 35, so FC is going to be 35. And then we're going to have some right triangles, it looks like. So we're looking for GD, which is going to be this little segment here. So we actually have this right triangle. So x squared plus 35 squared equals 37 squared. So x squared, here I'll just do the calculator, equals 144. And then the square root of 144 would be 12. So that gives us GD is 12. All right, last one, BG. BG is this one. So again, you want to look at your right triangle. So this side's going to be 12 right here, EG. So we're going to do 6 squared plus 12 squared equals x squared, which gives us 180 equals x squared. So x equals 13.4. So when I solved this one, GD, I got 12, and these segments are all congruent to the sides. You're welcome. Thanks for asking. Yes. What'd you say? I know.